Hey guys, welcome to question FM397 of the Further Maths Fortify study guide. So this question reads, a king requires guards to keep watch over each of his castle walls. Let X be the number of captains required to watch over a wall. Let Y be the number of corporals required to watch over a wall. The inequality below represents a constraint on the relationship between the number of captains and the number of corporals required to guard a wall, and we're given this first constraint, which is 3 times the number of corporals should be less than or equal to the number of captains plus 7. So question A wants to know if 2 captains are required, what is the maximum number of corporals required? So here we're going to use this inequality that's given to us. And what we're told is that 2 captains are required in this scenario. So we're going to start off by just replacing this x here with a 2. And now we're going to go through a bit of a simplification. Less than or equal to 9. So we're treating the less than or equal sign just like we would an equal sign. So what we should end up with, if we divide both sides here by 3, we should now end up with the number of corporals should be less than or equal to 3. So what is the maximum number of corporals required? 3, because of this or equal to. So if it was just y is less than 3, then the maximum of course would be 2. But since we've got this less than or equal to 3, our maximum becomes 3. We're then told about 3 more constraints. So we've got constraint 2, constraint 3, and constraint 4. B says to interpret these 3 constraints in terms of the number of corporals and the number of captains required to guard a wall. So if we start with maybe constraint number 2, well, we've got an x here, which should be the number of captains. So the number of captains should be greater than or equal to 2. So we might put it in context and say the number of captains required to guard a wall should be greater than or equal to 2. So that's what we're being told here, that we should have at least 2 captains guarding each wall. Looking at constraint number 3, we've got y is greater than or equal to 0. So essentially this is somewhat the same, the number of, except this time we're looking at corporals required to guard a wall should be greater than or equal to 0. So we could have no corporals on a wall, or we could have up until, well, you'll see the next amount of numbers that we're going to go through here, but it's possible for us to have 0 corporals on a wall. That's no worries, but we need at least 2 captains guarding each wall. Constraint number 3, so this one might be a little bit trickier. So we've got x, which is the number of captains, plus the number of corporals should be less than or equal to 9. So in this case, should probably make this one different to the last. We might write something to the effect of the number of captains and corporals. And we could put something in here to be very specific, like as a sum total. So we're letting them know that add the captains and the corporals together, should not exceed 9. The reason we say should not exceed 9 is because it could be 9, once again thanks to this or equal to, or less than or equal to. It can be 9, cannot be 10. Once again, if this was just a less than sign, then it should not exceed 8. So a little bit of wiggle room there. We're then given a nice little graph that looks a little bit like this one. So showing a functional region. The shaded region of the graph below contains the points that satisfy constraints 1 through 4. So we're given this little graph here. All guards are paid to man the walls each shift. Captains receive 7 silver pieces per shift and corporals receive 5 silver pieces per shift. The total cost of the crown C per shift is given by this little equation here. C equals 7x plus 5y. Determine the maximum cost to the crown per shift. So we've got a couple points here that we might want to start looking at. So if we were to take the 4 points of this little graph here, we could have 2, 0. So this is one little corner down here. We could have, make that more like a 2. We could have 2, 3. We could have 5, 4. Or we could have 9, 0. So in each of these scenarios, so for example here, this first one says, well, we could have 2 captains and 0 corporals. Now, we know straight away that that's not going to be the maximum cost of the crown per shift because we're paying 2 captains only here. And in just our next option, we've got 2 captains and 3 corporals. So the only difference between these two is that we're paying 3 corporals more money, which means this is definitely going to exceed the cost of just paying 2 captains. So we can immediately rule that out. We can also immediately rule out this 2, 3 because our next option is 5 captains, which is more captains than we had before, and 4 corporals, which is also more corporals than we had before. We can then eliminate this option here, the 5 captains and 4 corporals, because in our next option, we have 9 captains total. Whereas over here, we've got 9 people total, but we've got 5 captains and 4 corporals. We also know that corporals only cost 5 silver pieces versus a captain's 7 silver pieces. So having 9 captains is going to cost more than having 5 captains and 4 corporals, because both of them contain 9 people, but in the 4 corporal option, you're going to be paying the corporals slightly less. So we know that this point here, this 9, 0 is going to be our maximum out of these 4. So if we plug it into our cost equation, so C equals 7 times 9 plus 5 times 0. So we've taken this cost equation here and replaced the values with these coordinates. We should get C equals 63. 7 times 9 is 63, 5 times 0 is 0, 63. So the maximum cost of the crown per shift will be 63 silver pieces. Excellent. Now, we're given a little bit more information once again. So we're told that it's wartime and new minimums of corporals and captains are required. Therefore, constraint 2, which is x must be greater than or equal to 2, is replaced with x must be greater than or equal to 5. And constraint number 3, y is greater than or equal to 0, is replaced with y is greater than or equal to 3. Constraints 1 and 4 remain the same, and the total cost of the crown per shift remains the same. Question D wants to know how many captains and corporals will be stationed to a wall during wartime if the total cost to the crown is to be kept to a minimum. Write your answers in the boxes below. Now, this question may actually seem more complicated than it is just because there's a lot of information that's being dumped on you. However, the important thing to sort of look at here is that all that was really changed is the minimum number of captains and minimum number of corporals that can be stationed to a wall at any point in time. So now, instead of the minimum number of captains being equal to, well, being able to be 2, the minimum number, well, x must now be greater than or equal to 5. So the minimum number of captains needs to be 5. So if we kept that, if we kept the number of captains to a minimum, we would have 5 there. In your books, of course, these are side by side, but I'm just drawing them down here just to keep the space a little bit more neat. But the corporals here, now they've changed. Instead of having a minimum of 0 corporals, the number of corporals must be greater than or equal to 3. So keeping the corporals to a minimum, we'd have 3 corporals. And there are your 2 marks there. Alright guys, if you have any questions about these, please leave them in the comment section below. Otherwise, I'll see you in the next video.